Why is open hole logging important? It comes down to reservoirs and then actually reserves, or how these E&P companies eventually are valued. Reserves are a measurable value of a company's worth and a basic measurement of its lifespan. And whatever method used, whether it's volumetric, material balance, production history, or analogy, they all require a precise measurement of what we call original oil in place, otherwise known as OOIP, or with respect to gas, OGIP. The key components to determining OOIP are the volume of the porous oil-bearing rock, how much rock is there that is oil-bearing, the precise porosity of the rock, the water saturation, and the gas to oil ratio, otherwise known as GOR. So the more precise the OOIP measurements, the more accurate the reserve estimates. And ultimately, it's a significant portion of the E&P's valuation. In fact, every year, the 100 largest public U.S. E&P companies cite what they consider their risk factors in their 10K filings. And it's no surprise, the risk factors are analyzed and ranked in order of frequency cited. RECON's more precise data provides more accurate reserve measurements and helps mitigate these risks. It's all about data, precise data that is. RECON has developed its own open hole logging tools and telemetry system. Our sample rate is up to 4 times greater than Schlumberger, Halliburton, Baker Hughes, and Weatherford. So we get the very best picture, and we do it with less time in hole, saving the E&P rig time and expense. An investment in RECON's Pinpoint second-generation logging suite not only allows RECON to compete in 95% of the $1.2 billion market, it provides valued offerings to the customers, and for RECON in its market space, a sustained competitive advantage. And we'll get into better completion programs a little later in this presentation. To illustrate the RECON advantage, here's a recent example of a log-off between RECON and Weatherford. It's a heavy oil well that was cored, so the actual core or rock samples were brought to surface to be measured. RECON went in and logged the well using 3 passes, and Weatherford did the same. And both companies did this to illustrate repeatability. In other words, were they measuring consistently? And both companies passed that overwhelmingly. Weatherford is the log on the left and RECON is the log on the right. Reservoir evaluation and reserves determinations are based on multiple inputs about the rock, completions, and the production strategy employed. But again, getting back to OOIP and OGIP, the first and foremost, all companies must define the endpoint. The endpoint is defined by OOIP or OGIP of a given drainage area for the reservoir. To get this, we must look at the rocks in question. 2 of the very fundamental measurements made by logging tools that are quintessential in determining the reservoir quality and subsequent inputs into OOIP or OGIP calculations are the gamma ray, and that's on both of these logs to your far left, and the bulk density. Fortunately for us, and I guess all geoscientists, these are 2 measurements that are easily made on core and can be related back to logs very simplistically. Gamma ray is the natural radioactivity of the rock. This natural phenomenon remains the same whether the rock are in situ, in other words, in the ground, or at the surface when the core is brought up. When comparing gamma ray readings on the core at surface and those of the 2 companies downhole, we see that there is a significant variance in the Weatherford data of the core measured data in the area of like 15 to 20 API. The RECON data has a tighter fit or tie to the core data, with the variance being between 2 to 5 API. And what's even more interesting about this data is that the data was analyzed, the core data was analyzed at Weatherford Core Lab. But again, why is this important? Gamma ray is a fundamental measurement for determining the cleanliness of the reservoir, how shaly, dirty, clogged the porosity is. In fact, gamma ray can be a deciding factor in whether or not to pursue development. Bulk density is the basic measurement that is ultimately converted to porosity. This is done via a linear conversion of bulk density based on the grain density or matrix of the rock. And we can see the grain densities illustrated by the triangles on the right, the blue triangles. This is done via linear conversion of bulk density based on the grain density or matrix of the rock. We see that in this case, the grain density is close to 2.645 grams per cubic centimeters, which tells us that using a sandstone matrix as our conversion factor to porosity is correct. The most interesting part of this log-off is that the Weatherford data from the logs does not have a great tie to the core data, whereas the RECON log data is more precise to that of the data gathered from the core. As bulk density is fairly simplistic measurement, a piece of rock weighs so much and displaces a given amount of fluid, this value is one of the most reliable data points to tie back to core. Why is this so important? Well, bulk density that is higher than that of core will convert to porosity lower than that of rock. So in this particular case, we can see that Weatherford log data will ultimately yield lower porosity values for the rock. The lower the porosity of the rock, the less space there is between the rock to hold hydrocarbons. A poor characterization of porosity, whether it be higher or lower, has a great effect on the accuracy of the OOIP or OGIP number. It is very important to have the most precise measurement of this fundamental property. So now we get into OOIP calculations. And with respect to the coming zone, which was the intended target, the intended reservoir that this company was after, the RECON more precise data logs show an increase in OOIP of 23.2%. That is significant. RECON doesn't make it up. It just provides the most accurate or precise picture. And to further illustrate that RECON is the most precise, this well was over 7 stacked reservoirs. And RECON showed an overall increase of 14.7%. Some were obviously higher, some lower. In fact, all of them were just that much more precise. For the big three to provide the same level of resolution, they would have to undergo a serious retrofit. However, they are significant players with revenues ranging from $14 billion to $48 billion, and we don't take their presence lightly. RECON does have, however, a unique selling proposition in its high definition data, or otherwise known as HDD.